when we carry out a reaction in the lab, typically the mole-to-mole ratio of the reactants that we mix is not going to match up with the mole-to-mole ratio in the balance equation. So when that happens, one reactant will run out first before the other one does. Okay, so the reaction will eventually have to stop when one reactant is consumed, assuming the reaction goes all the way. So the reactant that puts a limit of the amount of product that you can obtain from a reaction is called your limiting reactants. That's the one that would run out first. I'm saying would because it's conditional. It doesn't have to run out, okay? But if the reaction will go to what we would call 100% completion, it will go all the way, then you say that the reactant that would run out first is called your limiting reactant. By the time that reactant runs out, that's it. You can't get any more product. So it puts a limit on the amount of product you can get. Now you have to realize a limiting reactant is not necessarily the smaller amount, because the amount, the rate at which it would be consumed compared to the other reactant would depend on the coefficients in the balance equation. Let's just make a simple example. Let's say you want to make a sandwich. Let's get an analogy. Okay, so you want to make a sandwich. You have 2 slices of cheese, right? Let's say you have 2 slices of cheese, okay, and you have let's say I have 3 slices of cheese, okay, and let's say I have 4 slices of bread. 1, 2, 3, 4 to make a sandwich. But so to make a sandwich, I'm going to need 2 slices of bread to react with 1 slice of cheese to make a sandwich, right? A sandwich would have a formula of B2C. So C plus 2B would be a reaction, yields B2C. Okay? Now I have 3 slices of cheese and 4 slices of bread. What's my limiting reactant? What's my limiting ingredient? Well, you could say, let's see, these 2 slices of bread and that slice of cheese would give me 1 sandwich, and the other slice of cheese and 2 slices of bread would give me the other sandwich. So my maximum yield, my theoretical yield, the most I can make is 2 sandwiches. So I ran out of bread first. Even though I have more slices of bread than cheese, I ran out of bread first because of this coefficient of 2 in the balance equation. So my limiting ingredient here would be the bread. My excess reactant, my excess ingredient would be the slices of cheese. Okay? So the amount of product that you can get if your limiting reactant were completely consumed is called your theoretical yield. So in this analogy we have here, our theoretical yield would be 2 sandwiches. Percent yield would be the actual yield compared to the theoretical yield. Theoretical yield is if the reaction went all the way. It may not. Typically, it won't go all the way. So the actual amount of product that you get in the lab, compare that to your theoretical yield. That's called your percentage yield. Usually express that as a percentage. So that ratio multiplied by 100 is your percent yield. Okay. To make you understand this concept of percent yield, let's go back to our analogy here with the sandwich. Okay, I say our theoretical yield here is 2 sandwiches, but you know, if I'm not hungry, I'll just make 1 sandwich. So my percent yield will just be 1 out of a possible of 2. So that's a 50% yield.